Have you ever wondered how life on Earth could have thrived billions of years ago when the sun was significantly fainter than it is today? This question brings us to an intriguing paradox known as the faint young sun paradox, a puzzle that has intrigued scientists for decades. Let's first understand the basic premise. According to astrophysical models, around 4 billion years ago, our sun was a young star, still in its early stages of life. At this youthful stage, it was only about 70% as bright as it is now. Now you might be thinking, if the sun was so faint, how did the Earth manage to stay warm enough to sustain life? Indeed, this is where the paradox lies. Despite the sun's reduced brightness, geological evidence paints a picture of an early Earth with a climate that was warm enough to sustain liquid water and, consequently, life. We have evidence of rivers, lakes, even early oceans, all of which require temperatures above freezing. This is where things get interesting. When we combine these two pieces of information, a faint young sun and a warm early Earth, we end up with a fascinating paradox. The conditions necessary for the existence of liquid water seem to contradict the astrophysical models of a faint young sun. So we're left with a question that has puzzled scientists for decades. How was our planet able to maintain a warm climate suitable for life under a faint young sun? This conundrum, my friends, is what we call the faint young sun paradox. But don't worry, we're not leaving you hanging with this paradox. In the following sections, we will delve deeper into this intriguing phenomenon, explore the proposed solutions to this paradox, and discuss the impact it has had on our understanding of Earth's history and future. So, how did life manage to survive under a faint young sun? This is what we call the faint young sun paradox. Stay tuned as we unravel this mystery. To understand the paradox, let's first delve into why the sun was fainter in the past. It all comes down to the fusion process within the sun, an intricate dance of atomic particles that powers our very existence. The sun, like other stars, operates on a nuclear fusion engine. In its incredibly hot and dense core, hydrogen atoms are compressed and heated until they fuse together, forming helium. This fusion process releases a tremendous amount of energy, which radiates outward as light and heat, providing the warmth and illumination that nurtures life on our little blue planet. But here's the catch. This fusion process isn't static. Over billions of years, the sun has continuously been burning hydrogen to form helium. And as more and more helium accumulates in the sun's core, it causes the core to shrink. This shrinkage, in turn, increases the pressure and temperature within the core, speeding up the fusion process. And what happens when fusion accelerates? The sun becomes brighter. This means that our sun today is significantly brighter and hotter than it was in the distant past. To give you an idea, scientists estimate that around 4 billion years ago, the sun was only about 70% as bright as it is today. So here we stumble upon the paradox. If the sun was so much fainter in the past, our planet should have been much colder. In fact, if we follow the logic, the early Earth, under a faint young sun, should have been a frozen wasteland, incapable of supporting liquid water, let alone life. But that's not what the geological evidence shows. The geological record reveals a different story, one of liquid water and thriving life forms even under the faint young sun. This contradiction between the expected and the observed is what we call the faint young sun paradox. So with a fainter sun in the past, Earth should have been a frozen wasteland, right? But that's not what the geological evidence shows. Stay tuned as we unravel the solution to this paradox in the next scene. So, if the sun was weaker in the past, how did Earth stay warm enough for life? This is the question that has puzzled scientists for decades, leading to numerous theories that attempt to solve this enigma, known as the faint young sun paradox. One of the leading theories suggests that the Earth's atmosphere may have had a stronger greenhouse effect in the past. This theory proposes that our planet could have had higher levels of greenhouse gases, such as carbon dioxide and methane, which would have trapped more heat from the sun, keeping the Earth's surface warm enough for life to exist. Imagine a thick, cozy blanket wrapped around the Earth, keeping it snug and warm even as the sun was faintly glowing in the distance. That's the kind of effect these greenhouse gases could have had. They may have acted as a thermal blanket, absorbing the sun's energy and re-emitting it back towards the Earth, thereby preventing the heat from escaping into space. Another theory suggests that there was less landmass in the early days of Earth. A smaller land area would mean larger oceans, and as we know, water absorbs more heat than land. So, with more water to absorb the sun's rays, the Earth could have stayed warm, despite the sun's faint glow. Think of it like this: you're at the beach on a sunny day. The sand gets hot quickly, but the sea remains cool. However, the sea retains its warmth long after the sun has set, while the sand quickly loses its heat. This could be how the Earth, with its vast oceans, stayed warm even with a faint young sun. Yet, despite these compelling theories, the faint young sun paradox still remains an enigma. Each theory presents plausible solutions but also raises new questions. For instance, how did the Earth maintain a balanced carbon cycle with such high levels of greenhouse gases? Or, how did the early Earth's geology allow for such vast oceans? While these theories may provide plausible solutions, the faint young sun paradox remains an intriguing question in the field of astrophysics. It's a testament to the enduring allure of the cosmos and the mysteries it continues to hold. The faint young sun paradox isn't just an academic curiosity. It's a scientific riddle that offers a deeper understanding of our world and beyond. By studying this paradox, we gain insights into the delicate balance of our planet's climate system. It illuminates how changes in solar radiation can impact Earth's temperature and atmosphere, shedding light on current issues of climate change. But the implications stretch even further. The paradox also provides a unique lens to explore the potential for life on other planets. By understanding the conditions that allowed life to thrive on Earth, despite a cooler sun, we can imagine similar scenarios playing out in distant solar systems. This could potentially guide our search for extraterrestrial life, broadening our horizons in the cosmic quest for understanding. So the next time you bask in the sun's warmth, remember the paradox of our faint young sun and the mysteries it continues to unfold. And if you enjoyed this video, don't forget to like, share, and subscribe for more intriguing science content.